Good morning. Today I would like to start by talking about the background and give you some technical introduction about Python before we begin to actually using it. So Python was originally conceived in 1980s. The first version of it was released in 1990s. And since then, it has become one of the primary tools in very diverse areas, such as in data science, AI, and machine learning. We will actually see a little bit more of this later. Almost like the first notable and prominent version of Python, version 2.0, was released in the year 2000, and it went through various updates until in the year 2020, this year, it was announced that it will be no longer supported. During the period of its development, almost overlapping to some extent, version 3.0 was developed, and 3.0 kind of matured to the point that it overtook the prominence of version 2.0. And going forward, version 3.0 is the only one that will be supported. Python primarily gained its momentum because of various attributes. Readability of the code, ease of development, and availability of extensive libraries contributed to, are some of the components that actually facilitated its quick growth and adaptation by the programming community. So some of the technical aspects of Python, for those of you that might be a little bit more technically oriented and familiar with other programming languages, it is an interpreted language. It does not need to be compiled, such as, for instance, let's say Java and C++. And because you just simply write a code and you execute it, it kind of lends itself well for being a scripting language. However, because it is not compiled, it's inherently a slow execution program. So it is not really a platform of choice for development of numerically extensive and compute-demanding algorithms. For those kinds of algorithms, it is probably better to use C++, potentially Java. It has an automatic garbage collection routine, unlike, for instance, C++ that requires dynamic memory management explicitly defined by the user. Python does not require that, and it performs all the memory collection allocation all automatically behind the scenes. It's dynamically typed. Again, unlike Java and C++, Python does not require to have type indicated for variables. You do not need to worry about whether something is an integer or float or string. It will automatically make decisions for you, and if the decision is not appropriate, you can easily cast it from one type to the other one. And again, that will be some of the things we will see later. Another contributing factor why Python is such an attractive, easy to learn and utilize programming language is that it supports procedural, functional, and object-oriented programming paradigms. So for those people who learned programming in 70s, 80s, 90s, and forward, it essentially accommodates all those programming skill sets. Procedural functional programmings have been around for a long time. Object-oriented programming have been introduced in more recent history of computer science. So therefore, a big portion of the programming community can just jump onto Python and bring some of their previous experiences. So as far as the pragmatic aspects of what we're going to do in this class, version 2.0 is no longer supported. We are going to exclusively do everything in version 3.0. And incidentally, version 3.0 is not backwards compatible. So if you have a code that was written in the era of 2.0, for 2.0, I believe 7 was the latest version of Python 2. If it was written for 2, it may not run in 3, and therefore you may be required to download and utilize Python 2 instead of Python 3. So be aware if things are not backwards compatible. I'm going to give you a very quick demo of that. Python emphasizes readability. it's very forgiving in code. You can almost like sit and write something in a plain English and it may actually work. Whereas in many other languages such as C++ and Java, again, that is not the case. Most programming languages, they kind of combine collection of expressions as a block of code, and they do this by curly brackets. Python is very different than those in that white space is indicator of blocks. So if there's a block of code that's indented, then that portion that's equally indented is going to be considered to be a block of code. So it becomes a little bit tricky because if things are off by a space or two, then suddenly your program may misbehave and do something completely different. This is something that if you're not using an integrated development environments that will manage it for you, you have to pay careful attention to it. So Python is, in a way, considered to be batteries included language because when you get Python, not only Python itself is fairly complete, but it comes with many other libraries that completely extend the functionality of your Python programming in specific arenas, such as we will see later on. There are packages that will completely enable huge programming exercises and condense it into a single command call in genomics and bioinformatics analyses. You can perform machine learning AI very easily. You can develop neural networks, visualization, data and analytics very easily. You can expand your Python in many directions. And of course, because of its ease in development, additional libraries are up and coming. So for my purposes, I work in Linux environment. Python, by the way, Python interpreter is available on all platforms imaginable. It's on Windows, Mac, Linux, which pretty much covers most of the operating system that people use these days. You can use Python in the interpreter, or you can use it as, you can write a program, a collection of commands, which then will be evaluated and executed at the same time. I am going to start with interpreter as a quick demonstration, and then I'm going to move into programming environment. I am going to use simply VI, that's just an editor, in order to write my scripts, and I'm going to use command line in order to execute them. If you're in Linux or Mac environment, you can do this almost parallel with me, but if you're on Windows, it's going to require a little bit more knowledge of what you're doing. So you may want to just jump straight into integrated development environments. There are many examples out there. I'm going to use, later on, I'm going to use PyCharm, but PyCharm, IDLE, Python, PyDev, number of other ones exist out there. So feel free to use whichever one suits you. You can also use Python and either install it, use it by either simple editor and command line execution on your own desktop, or you can completely use virtual environments and online environments. I have one example here. There are a number of Jupyter Notebook-based Python tutorials and Python basically evaluation environments. You can go there, you can develop a code, you can, for learning purposes, should suffice. The only issue is going to be that once you have written a program and you want to execute it to process your own data, and it may take a long time, there may be issues related to security of the data and a variety of other reasons, you may at that point want to implement a version of Python on your own desktop. But for now, you can even use online versions in virtual environments. So what I want to do, I want to start with some demonstration of Python. So as I said, I'm going to start the whole thing in command line environments. So in Windows, it's terminal that you basically can invoke. In Mac and Linux, they are pretty much the same method that you can, I'm sorry, let me focus on doing this first. Okay, so I have opened up terminals in here, and what I can do, I can just invoke Python interpreter. I will be presented with this environment, which a single Python command can be entered, and then the interpreter will execute it for you. Now, the first thing that I want to start is by what is called the print statement, or StadardIO, standard input output. Your computer has many devices that bring information from the user to the computer. These are called input devices. And some simple examples of it will be keyboard and mouse. Almost everybody these days has those two devices. These two devices bring information from human to the computer. And then there are devices that are used to deliver information from the computer to the human. And that would be, for instance, examples of it would be printer or your monitor. So these devices have names, they are technical names, they have some common names. But in the field of computer science, the standard input and standard output devices are considered to be exclusively keyboard as your standard input and monitor as your standard output. So when I say standard input, I'm talking about keyboard. When I say standard output, I'm talking about monitor. So one of the first things that we're going to learn always in all programming languages is how to instruct the computer to echo something onto the screen. The command is called print. It is the content of what you want to print is embedded within the parentheses. And if you want to print out a string, will be something like hello world. And once the double quotes indicate the beginning of string and the end of the string, and the entire contents of what needs to be printed onto the screen is embedded within the parentheses. Once you press enter, the program will execute and will echo onto the screen the string called hello world. I may want to, for example, break this up. I may say print the first prime number is, terminate this and append it or concatenate that string with the number 2. And my intention in here is to direct the programming language Python to echo onto the screen the string, the first prime number is, followed by number 2. And if I do this, in Python, I get this particular weird notation that is sort of did what I wanted. I did not want the single quotes. I did not want the parentheses. I did not want the comma. I just simply wanted it to say the first prime number is 2. And this is an illustration of the difference between Python 2 and Python 3, which is what I'm going to show you next. So when a Linux environment, by default, when you execute Python, it will bring you to Python 2.7, as you can see here. It's Python 2.0. And as I said earlier, Python 2.0 and 3.0 are, in some instances, significantly different. So here, I'm going to quit out of Python 2. I'm going to go to Python 3, do the exact same thing, show you that it works. And from that point forward, I am going to exclusively work in Python 3. To quit the environment, you issue the quit command with the parentheses, and you get out. To invoke Python 3, I need to explicitly say Python 3. And now I am in Python 3.8, as you can see up there. And this is a note of caution to people who are Mac environment, Linux environment, possibly in Windows environment. If Python is pre-installed, chances are Python 2 is installed. And in Linux, by default, both of them are actually installed. But by default, Python points to Python 2. So be careful what you're doing. So in Python 3, again, I can say print, and space kind of doesn't matter in this sense, hello world. And it will do exactly as Python 2 behaved. But if I say first prime number is 2, this now behaves the way that I intended, and it's different than Python 2.7, 2.0. What else? So print essentially is going to act as a function of echoing information to the user. It is usually used at the beginning of a program and usually at the end of the program. It usually serves as a method of gathering information from user before proceeding with an analysis. That's at the beginning of the program. And it usually also is used at the end of a program where some sort of analysis is done and the results are then provided back to the user. Print statements typically are used at the beginning, at the end of the program. However, there are some instances, of course, that additional information may be required during the execution of the program or for debugging purposes. So print statements can be used anywhere, of course, but typically they are used at the beginning and the end of the program. So in just entirely the paradigm of programming is to put together a set of expressions and commands that perform a useful task. And to perform a useful task, you get information from the user, you perform something useful, and then you provide information to the useful information to the user. So to do this, you need to receive information from user in order to operate on it. And that particular command is called input. By the way, so if any of these commands you need to have additional information, you can look them up on Google, of course. So just saying Python print documentation, you can go here, set of standard commands, you click print, and it will give you a very concise description of what print can do with all the arguments that it takes. And then you can use whatever component of this print function that you want. I'm going to gradually over time, I'm going to talk about various different components that go into print statement. So I may say, let me just do a couple more things. So the command is input. I can say input. Input takes one argument, which may be a prompt that it is going to echo onto the screen. So I can say input, please enter number. When this is executed, the text string that is part of input will be echoed onto the screen. Program execution will be paused. And at this point, your computer is waiting for information to be entered by the user. When the user, for instance, puts some sort of a number in and presses enter, this number is received, this number is parsed, and appropriate things will be done with that particular information that the user provided. In this particular case, automatically it will be reflected back onto the screen. So at this point, I want to start a topic that very superficially, and later on I'm going to expand on it. I want to get into the different variable types and data types that exist in Python, but I'm going to cover that in the next lesson. But when you are printing things, it could be a string that's embedded within double quotes. You can also include various arithmetic and mathematical operations. So here I can say 2 plus 2. 2 plus 2, as it's written on the screen right now, it indicates an arithmetic operation where two numbers are added, the result is returned, and the return value is then operated by whatever the command you have there. So this is really two commands. 2 plus 2 is going to be evaluated, a value of 4 is going to be returned, and value of 4 is going to be passed to print function, which then prints 4. All arithmetic functions are available here. Here's multiplication, here's subtraction, and here is division. Additional operators are available, modulus, and a number of things, exponentiation, logarithm. Some are part of plain Python. Some of them require additional libraries to be loaded and used. So what I want to do at this point, I want to get out of here and start exercising the concept of writing a program. So let me switch to the proper. I'm just going to write things here. My first program.py. So I am going to create a Python script, Python program called my first program. And by default and by expectation, I'm going to put my file extension to be py. File extension of py, like many other ones, doc indicates a Word document. Py indicates a Python, and that's kind of standard in the field. So when you're writing a program, essentially you're combining number of commands into one set, and then when you execute that program, individual commands are executed sequentially one at a time. So for instance, my program may start by hello world. So I want to write a program that will perform the following. So it's going to print all that information, and it's going to give a bit of description of what it is that it's going to do. I will get a number and double it. So the very first thing that you're going to do, the program is going to prompt the user in order to receive a number. So here we're going to use the input command. It's going to say, please enter a number. And by the way, what I am showing you now is what I intend for it to do. And it's going to do a weird thing just ahead of time, no heads up, that I'm going to try to explain why it is doing what it is doing in the next session. So I'm going to prompt the user to say, input a number. So this process, as we talked about, is going to echo the string, please enter number onto the screen, and it's going to wait for user to input a number. And the number that has been entered by the user needs to be temporarily stored somewhere inside the program in order for the program to do something useful with it. So here we're going to use what I'm going to introduce the concept of variables and containers, my number, and I'm going to use the assignment operator. Equals, a single equal is called the assignment operator, which assigns the value of what is on the right side of the expression to the left side of the expression. The left side of the expression is a variable. Right side of expression is a command which is going to receive a number from user and then is going to store it in my name. And the very first thing that I want to do, I want to print the very first thing that I want to do is to echo the number back and just make sure that everything is okay. So at this point, my recommendation to all beginning programmers is to never write the entire program and test it, and just do it incrementally at a time. So if I was to follow my own advice, I would write the first 3 statements, stop, compile, run, actually not compile, just run, and confirm that it is working. And then from there you proceed. Even though it's a very simple statement, the 3 consecutive statements, in my years of programming, I have seen programs that contain basically some weird invisible characters that your simple editor may not show, and it really throws your programming off. In this particular instance, I have written the entire thing, so I'm going to test it here. To test it, to run it, I'm going to say Python. I have to invoke Python 3. And I'm going to give it the name of my program. And my program runs as expected. Hello world, my name is Hamid Alfar. I will get a number and double it. And so that was the first 3 lines. The 4th line is an input statement, which the input statement echoes onto the screen. Please enter a number, awaits my number. So I'm going to say 2.5. And the first thing that I am doing with my program is to echo the number back up and just make sure that I got it. And I got it. It seems like, at least based on this information, I received the number fine. So the next thing would be to actually perform the function that the program is supposed to do. So this case, then all I'm going to do is that the number doubled is 2 times my number, which should put whatever number I have is entered, it should just double it. So if I run it again, give me a number, I'm going to give it 2. It gives me 22, not 2. If I run it again, this time if I say 2.5, it gives me 2.5, 2.5. So for those of you with programming experience, you may actually know what exactly is happening, but this is going to be, explanation of it is going to require transition to a different topic, which I'm going to stop at this point, and I'm going to explain this phenomenon, what's happening in the next in the next video. So please let me know if you have any questions, if anything does not make sense. Thank you.